The main function of the diode is to allow the current to flow from the anode to the cathode and not the opposite way. More specifically, when the voltage at the anode minus the voltage at the cathode is exactly VD, VD is the turn-on voltage of the device. It ranges between 0.3 to 0.9. Then the diode is on and can be represented now by a voltage source of VD. Be careful with the polarities. When that happens, a current has to flow from the anode to the cathode. There's no universe where the diode is on and the current is not being conducted from the anode to the cathode. So we always have to have a current flowing here. Now, when the diode is off, it's represented by an open circuit. We understand why, because no current is being allowed to be conducted from the cathode to the anode. And when does this happen? When VA minus VC, the voltage at the anode minus the voltage at the cathode, is less than VD. So when this is less than, let's say, 0.7, this diode is off. It's nothing but an open circuit, and no current is being allowed to be conducted. By the way, it's important in our circuits to identify the anode and the cathode, just so we can write these equations very, very easily. Let's check an exercise just so we understand that what we're talking about. It's very basic. We have a voltage source, a diode, and a resistor. Now I redraw the circuit over here, so this is the same circuit. And I'll say that there are two cases where either the diode is on or the diode is off. And I will draw here the current in respect to the input voltage. Very common style of exercise. Now the first thing is to identify the 2 points. So this point and this point. I'll call this A and C for anode and cathode. You can name it however you want. When did we say that the diode is off? When VA minus VC is less than VD1. You can also see it called VD1 on. So when this voltage difference is smaller than VD1, this diode will be off and the current will be 0. When will this happen? Well, if the current was to be 0, then this point, C, would have the voltage off all the way to here. So it would follow the voltage from here. Why? Because no current would be conducted here, so there would be no voltage drop on this resistor. That means that VA minus VC in reality is V in. So when the diode is off, this is represented by an open circuit. No current is being conducted over here. This VA minus VC is equal to V in. Therefore, so for these voltage differences smaller than, let's say, VD, the current will be 0. This will be an open circuit up until a point where this VA is going to be, this VA minus VC is going to be equal to VD. So when VA minus VC becomes equal to VD1, then this will become a battery, a voltage source of a voltage VD1. This is A and this is C. And now we can do perhaps a KVL over here, alright, in this loop. Let's name it loop 1. And from the KVL, we will figure out the following. We, first of all, would have a current, of course, because the diode is on and it has to conduct a current. And then when we perform a KVL on loop 1, we'd have that we enter a negative terminal, so I'll put it as minus V in. Then we enter a positive terminal plus VD1. And then we enter the positive terminal of the resistor. We suppose that we enter the positive terminal because the loop goes like this and the current, we suppose that goes like this. So this is plus IR. That means that all of this must be equal to 0. And that means that I will be V in minus VD1 over R. So from that point onwards, this is a straight line going upwards and has a slope of 1 over R. And congratulations, you've learned the basics of the diodes in the context of the circuits. Now we can go ahead and solve any type of diode circuit that we face, and as long as we remember the two basic conditions where VA minus VC is less than VD, the diode is off. When VA minus VC is exactly VD, the diode is on. You can do anything now. Let's dive deeper into diode circuits and more electronics concepts. Check out what I've prepared for you in the description below. Also click on this video right now. Study well and take care. Goodbye.